All right, today we're beginning chapter 3. These first few learning targets should go pretty quick because you've dealt with mean, median, mode literally since probably the middle school years, maybe earlier. But we'll also work on interpreting these. Sometime extreme data values like outliers affect these. So that's something maybe you haven't had a discussion on before, which we will. All right, we'll also get to what's the trim mean. That might be new. Weighted average might be new. But the first 3 learning targets, a lot of review. Okay, so that's going to go a little bit faster than the last 2. Okay, so I want to start right here on pages 92 and 93. I want you to read those pages. Pay attention to the difference, how we handle medians when the sample size is even versus odd. Means the number of your sample size, like size 10 to size 11. There's a little difference. So go ahead, give you about 2 or 3 minutes to read that. I'm looking for those differences, and then we'll continue. Okay, so that's why it's called measures of central tendency. Which of these 3 things is the best way to kind of explain the center of the distribution? All right, so mode, median, and average all kind of have their own role in these situations. So the first one's the mode, right, that you just read about. If you didn't write in this definition, do it now. The mode of a data set is the value that occurs most often or most frequent. Okay? It's the value. If you're going to shorten this up, just say value that occurs most often. All right, so the median, this did occur a little bit even in chapter 2, not that often, but we had a quick discussion on this. So now we'll formalize it a little more. When you have an odd set of data, there always is a true median. You first have to make sure it's in order from smallest to largest. Okay, so put your data set in order. So let's just say I had a real basic data set like this one, 81, 86, and 90. That's an odd data set, right? N equals 3. N is just sample size variable, right? So this is the median. 86 is, because it splits it in half, I have 1 on each side. Make sure it's balanced. If I were to move on to an even data set like this, so I just took the same data set, I added 92 to it. So this would be a sample size of 4. When it's even, we don't really have a true number in the middle splitting this in half. We kind of have that invisible number that's going to split it in half, right? That line right there makes 2 on each side. So then we just got to find this median by averaging these 2 middle numbers, the 86 and 90. So the median would be equal to, for this small example, 86 plus 90 divided by 2. It's also going to be the midpoint. It's another way you could think about it. Just the number you choose, make sure it's in the middle of 86 and 90, which would obviously be 88. All right, so you see the difference? Okay, even. Still make sure it splits the data in half, but you got to average the 2 middle. Odd data set, there is a true middle. Okay, of course, the mean is an average. Add them up and divide by the sample size. I think you probably have that down by now. All right, your turn. Give you a couple minutes to work through guided exercise 1. Really focusing on median and mode, but you're going to have to arrange this data set in order first. So let's take a little bit of time. I'll give you about 3 or 4 minutes to do this. All right, so here it is organized. All right, sometimes the data sets are this big. Sorry, not sorry, just the way data sets are sometimes. All right, so since there are an even number of values is what they were trying to have you decide on, right? Choose one of these. We add the 2 middle values and divide by 2 to get the median, as we addressed on the previous page. So what do we get? Well, it's 15. Here is the middle. Should be after the second 15 and the 13th and the third 15. All right, so you add those together, divide by 2. Obviously, we get 15. Okay. All right, so what's the mode? Is it different from the median? Yes, the mode is 12. It's a difference of 3. Okay. And if you're trying to create a budget, they're going to want to use the higher of the 2. You don't want to use the lower amount, and then all of a sudden your budget's low. So when it comes to budgeting things, you definitely want to probably choose the higher of the central tendencies. Not to mention, if we were to take the average and add all these up and divide by 40, just by looking at the data set, I mean, we do have 19s and 20s that are going to affect it. So I think the average is going to be closer to 15 anyways. So that's what you're going to want to use for the funding. Okay? Any questions? All right, so there's giving you some pointers on how to find that middle value when the numbers get high. Obviously, if they're small, like the opening example I gave you, 3 and 4, it's easy to see. But when you get up to like 99 or even the 40 on the last one, how could we figure out what that middle value is? So they're telling you we could do 40 plus 1 divided by 2. So that ends up giving me 41 divided by 2, which is 20.5. That tells me that the median is between the 20th value and the 21st value. Okay? So that's how you figure that out. If it's an odd number data like 99, you add 1 divided by 2, it's the 50th data value, and that is the true median. Okay? So that's what they're telling you. That's not really something you got to memorize. I mean, it's helpful, but you could also just list the data and make sure it's balanced, right? 20 on each side is what we found out in the last one. Okay. All right, give you a moment here to read what they're saying about mean, the average, and then I want to talk about all these symbols here. So I'm going to give you about 2 or 3 minutes to read for understanding all of this. Start paying attention to these symbols down here we're going to get to, and then we'll have a discussion to follow. Go ahead. All right, so sum over n, number of entries. Summation notation is, or summation symbol is something that some of you are using right now in your trig classes, or you've used before in your trig classes, like this. The sum of this sequence, n squared plus 1, from an n value of 1 to 8, something like that. That's called summation notation, and this is just a Greek letter for S. That's all that is. It's just like if we were doing this in English, I guess we'd just say that. All right, that's all that really means. Sum. Okay. All right, so some other symbols we're going to see. X with a line over top. That means sample mean. All right, so if I grab a sample of students and get their sample GPA, I say X bar equals 3.4, whatever it is, if it's 10 students. If I get the entire DHS population, we use a different symbol for population mean. It's mu. Okay? So that's the difference. Sample mean, population mean. All right? It's a lowercase Greek letter called mu. That's how we pronounce it. Mu. Okay? All right. Now, sometimes average is it's the most common measure of central tendency. No doubt about it. Okay? But sometimes it's not appropriate. It can be affected by exceptional values, meaning extreme values, whether a really high one or a really low one, which we call outliers, right? So exceptional values are talking about outliers. Okay? So another little read and then a discussion about resistant measure. Go ahead and read this important paragraph right here to yourself. Okay, some distributions are heavily skewed. Income is a great example. Let's just say we have any town, not just this town, but if we were to survey the median, the household incomes, right? And we start charting that, and zeros here, 50Ks here. I got it squished, sorry. Income, 0, 50K, 100K, and so on, okay? Now, this distribution is probably going to peak somewhere around here, and then it's probably going to be heavily skewed to the right. Make sense? Like some of the people are a little more wealthy, or they've got a big inheritance or something like that, or they just make a lot of money. Maybe Matt Stafford lives in the neighborhood or something like that. Oh, actually, he's leaving. He's moving. But it would look like this, right? Skewed right. So when you have outliers or something that's heavily skewed, we tend to like to use median. Okay, because they said what? It's more resistant to these outliers. Where if we're going to average this together and I throw in, a couple people make $1 million a year or $2 million a year, that throws the average off by quite a bit. Where the median, it doesn't, because it's the middle value. Okay, when you add somebody rich in the neighborhood, it just moves the median over one little place value. Okay, so I want to add this here. So for heavily skewed distributions, okay, which also includes big outliers, right? I think we understand that. We like to use median for our measure of central tendency to describe the distribution. Okay, it's the best measure of central tendency. We have heavily skewed distributions. But if it's not, and it's just a mound-shaped normal distribution, so for mound-shaped, we don't really need to. Either are fine. But we tend to use the mean just because people like averages better. It's a good measure of central tendency. All right, it's the most commonly used one. So for mound-shaped, we could use either. So I'll put use either, but mean is the most common. All right. So if they ask you they may give you a setting, say which one should we use, mean or median? You're going to base it off this. If it's skewed, we should probably stick with median because the average will be affected heavily by this. But if it is symmetric or mound-shaped, we'll probably just stick with the average or mean. Okay? All right. All right, let's go ahead and do a trim mean next. A trim mean actually is one way to get rid of these outliers. Okay, so what we're going to do for a trim mean, we always trim a specific percentage of the smallest and largest data values. We trim off the left and right if it's in order. Okay, so a 5% trim mean is used. This implies that we trim the lowest 5% of the data as well as the highest 5% of the data. Then we go ahead and find the mean. Okay, so we'd order it and just explain this, delete it, and then we compute the mean of the remaining 90% of the data. All right, let's go ahead and take a look at this. Go ahead and read that setting, then we'll do it. Okay, so the mean for the entire sample. What we do to find this mean is we'd add all these up. Okay, I already have the sum and the mean for us. So we'd add these up and we divide by 20. So the answer is going to be 35.95 or 36 if you round to the nearest integer or person because it's class size, right? So 36 people would be about the average. All right, notice I use X bar because it says the word a sample of 20 colleges and universities. It doesn't say all of the colleges and universities. If it did, we could use mu. So the appropriate symbol is X bar sample mean. Okay. All right, let's take a look at part B. Now it says compute a 5% trim mean for the sample. So when they say a trim mean, what we have to do is figure out what is 5% of the sample size. 5% of 20 colleges is 1. Right? So just 0.05 times 20 in the calculator, we get 1. So that means I have to remove 1 college from the top and bottom. So on this data set here, we'll take 80. That's got to be gone because that's 5% from the right. And then we take the 14 and we remove it from the data set. And then you find the mean again. So then we add these up, these 18 pieces of data, and we divide by 18. Okay? Trimmed mean, trim 5% off. All right, so if you want more there, I just gave an explanation. So take away 1 data point from each end, then find the new X bar. All right, so C, find the median of the original data set. This part's just kind of review. The median, it says original, and I'll go back to all 20 pieces of data. So they already put it in order for us. So it's going to be between the 30th and the 35, right? Because that puts 10 on each side. 10 data sets here, 10 pieces of data here. So 30 plus 35 gives me 32.5 for the median. Okay. All right, I'm going to pause here for a moment, let you do D. Find the median of the 5% trim data set. Did it change? Go ahead. All right, there's your 2 answers. We'll stop there today.